Hello, and this is USACO 2020 December contest bronze stuck in a rut. I will first read the problem as I explain it, then I will explain how to solve the problem on code. Farmer John has recently expanded the size of his farm. So from the perspective of his cows, it is effectively now infinite in size. The cows think of grazing the area of the farm as an infinite 2D grid of square cells, each filled with delicious grass. Each of Farmer John's end cows, 1 through 50, start out in a different cell. Some start facing north, while some face east. Every cow either stops if the grass in her current cell was already eaten by another cow, or eats all the grass in her current cell and moves one cell forward according to the direction she faces. So, what does that mean? That means each cow is either going straight north or straight east. That means every hour you add one to their current position. And let's say there's something in front of them. Let's say there's a place that another cow has already visited. Then that cow that came after will stop. Over time, each cow therefore leaves a bare rut of empty cells behind her. If two cows move on to the same grassy cell in the same move, they share the cell and continue to move in their respective direction in the next hour. So what that means is that, let's say two cows come into the same place at the same time. That means it will actually not create a rut, so the cows will continue to move. If Please determine the amount of grass eaten by each cow. Some cows never stop and therefore eat an infinite amount of grass. The input format. The first line contains n. Each of the next n lines describe the starting position of a cow in terms of character that is either facing north, which is symbolized by n, and e, for east, and two non-negative integers, x and y, which give the position of the cow. All x coordinates and y coordinates are different from each other. If you're moving north, it'll become x, y plus 1. And if you're moving east, x plus 1, comma y. And the output format, you print out n lines of the distances as seen here. So, like I just said, basically we're checking how far does the cow go before it stops eating. And the only time the cow stops eating is actually when another cow has already eaten. So, let's try coding this. Here I have the main method and init section where I will actually initialize the variables and solve. Solve is where I'm going to solve the things. So we need to make a few variables. First, we're going to make a scanner to actually get the information from for the code. And we'll make sure it's static because we will be using it throughout the code. Scanner that in static int n. Why am I making static int n? Because we're going to have n lines of input, and I need to know what that n is to make sure I run the code the right amount of times. We're actually going to make a variable, an integer variable called this, to keep a track of how far each cow will go, and static boolean stuck. This will keep a track of if the cow is stuck or not. That means is the cow moving or not. And then we're going to make these two linked lists. Static linked list cows. And these linked lists will keep a track of the cows. It will actually have the cow and it will tell you where that cow is at that position. And why does it say cows, basically? It shouldn't have integer or string. That is a good point. But for the sake of convenience, because we know that we need to know which cow, which position, we're actually make a new class that can hold all three. So down here, we're going to write static class cows. And in there, we're going to have the ID, the X value, and the Y value. And then cows int a. This portion of the class is actually used to initialize a variable called cows, and the order does matter. So make sure you keep the same order, or else the numbers will be jumbled around and actually mess up the code. And then we make a toString for printing it out, just in case we need to. ID plus A plus X Y. Okay, that we're actually not going to put a comparable in here just yet. We're actually going to do that in the initializer. So we will do that later. And if you look down here, why is this section green? Because we're actually going to put in the variable because USACO has changed their rules recently. They wanted from to be the scanner wants to scan it from the input section of the code instead of actually getting a new file. And this is the answer we're trying to achieve right now. I put it there ahead of time so we can actually see it, what we're actually aiming for. So let's make in. What is in? Once again, it's a scanner that's getting the inputs for the code. We have to call in it so the code actually happens, and then we're gonna have to close in and the code. Okay, so let's start initializing everything. N equals in the next int. Be careful here now, because after you write in that next int, if the next thing you want to check is like a string, character, anything but an integer, you want to write in that next line to make sure it does go to the next line. And then we're going to initialize distance, which is an array, new int, and we wanted n. We wanted a length of n because there are n cows. Same for stuck. And now we will initialize e and n for e for like as before, east and for north. And then we can just copy and paste that, to be honest. And because it is the same thing. So why E and N? It's because there are two categories of cows facing east and north. We're actually put them into these categories, and we're actually going to do that by using a for loop for int I equals 0. I goes all the way up to n because there's n cows, I plus plus. And we're actually going to get the three parts, the inputs that are given as a character, because characters are easier to compare to and are much more convenient than that next dot char at 0. If we don't have that char at 0 part, it will actually return a string. So we need to change that string into a character. That's why we're using char at x. This is for the sake of convenience. You don't need to put in that next line just yet. But up here, instead of putting in that next int, I will show you a different way you can do it. Integer parse int next line. What this will do actually is actually make the code much shorter. This is basically just changing every integer into an integer within a string, and that only works if the string is only composed of integers, no spaces, no nothing. And now what will we do? We check if D is the direction holding E or N is equal to E. If it's equal to E, we're actually going to put that into, surprise, surprise, the E linked list. So E dot add I X Y. But if you notice, if you remember, if you recall, I actually made ID an integer. Why would I have done that? Why do you think? It's simple. It's because I already know which direction the cow is going based on which linked list it's in. That's why it's labeled E and N. E for east-facing cows and N for north-facing cows. So I don't need to actually know which direction it's going because I've already put a method of organizing that. I'm going to do the same thing. If it's not E, it's obviously going to be N, so we can just use an else for simplicity, and voila. So now what are we going to do is actually we're going to make the comparator, or like how to organize your these two linked lists. Collections dot sort E dot new Parador. Cows. And then we're gonna write at override because all comparators need that. At override, public int compare USACO stuck in rut 2. So why am I writing stuck in rut 2? That's the file name, and we know that's where the cows belong. And since we know where it belongs, we need to write that down in this case. Copy and paste. Copy and paste will be your best friend because there's a lot of things you can do just to save time. As such, return O1.1 minus O2.1. And then you're done. That's going to organize the list based on your coordinate, your y coordinates, because the coordinates will be side by side. And we can copy and paste this because we're going to do that for the x coordinate, but instead of e for the n. So these are organizing two different lists, e and n. And if always check your code out, try it out to make sure you're not doing the wrong thing. And we're always going to have to check our code because checking your code will be important to make sure you don't have any bugs. And voila, it came out the way we wanted. Now we're going to move on to solve. So what is solve? Solve is where we're going to actually pair up the cows and see which ones will be getting stuck and which ones will be going to infinity. So we're going to go for cows, E and E. So what is each E will hold a different value of cows that is within the E linked list. We're actually going to do the same thing again, but instead of E, we're going to change it to N for north. And then within this, we got to check if they meet. So what will we do? Remember, there's this function we have called stuck. So we got to check if stuck at n.id. Why am I not putting anything after? Because it's a Boolean value. I actually don't need to write if equal to true. Or e.id. We got to check both. And then there's this condition, n.x is less than e.x. This means that the x value of the north-facing cow and the x value of the e-facing cow, they're different right now. And if e is bigger than that one, that means the cow at n will be stuck. Or let's say n.y is greater than e.y. That means the cow will be stuck in that condition. So we write continue because we already know that's stuck and we don't need to check that. That's useless. Waste of time. Then we get two different distances. Why are we getting these two distances? Which I'm going to label dx for n.x minus e.x. This is checking the distance between the x's and dy, which is going to check the difference in y values. So why am I doing this? Basically, I'm getting the distance between the two cows and seeing what I'm going to do is I'm going to make an if statement that checks which one's greater. And if dx is greater than dy, that means e must be getting stuck. So stuck at e.id, true. The distance at e of id will equal dx. That means the east going one has been stuck. Else, what happens? Let's say dy is less than dx. Why can't we just not write else? Because there's a case that dx might equals dy, and that's not what we want to encounter. We just want to check these two. So if those two, we're just doing the opposites in this case right now to actually ensure what we're doing is basically finding the distances between the two and seeing, oh, if it gets stuck here, you should print this. So now we want to organize everything within distance into one simple way we can print it. So we're gonna actually use a string builder instead of just printing of using a for loop, because it's much faster to actually just use a string builder. SB equals new builder. And then we're gonna use a for loop. And if n equals 0. So why are we checking if n equals 0? That means at this point, the cow has never met another cow. And dx and dy within these previous for loop has never affected this distance. So that means SB that append infinity. Because there is that case where things can go to infinity as because the cows just never meet and it's an infinite chess form. Else SB dot append and we gotta write SB dot append \n to make sure the things go from line to line, because if we look here, it's not all in one line, it's all on a separate line. And then we're gonna system that print. Remember, print, not print ln, just print. Because why is that? Because SB has a print \n at the end. That's adding an extra unnecessary enter, which is actually just gonna give an error. So let's see if this code is correct. Yes, it is actually correct. And before we submit it, we want to get rid of our testing cases up here to make sure it does not interfere with our code. So we're actually going to try submitting this code. And it's grading. USACO does have a time limit. So if it does go over time, it will tell you. And also, if you look here, I did get rid of this, but I forgot to save. And remember, you always got to save your code or else this will appear. And make sure you do get rid of it because USACO does count it as incorrect if it does exist as such. So, yes. Now we know it's not going to appear, so let's try again. And we try submitting. It's waiting for the grade server. If there's an error, there's going to be a series of green boxes. If there's an error, that means there's going to be a red box. If it's correct, it will just be green as such. And if we wait a few seconds, in 3, 2, 1, everything is correct. And that is how you do USACO 2020 stuck in a rut bronze. I hope you learned something, and I will see you next time.